Okay. Yeah. Yeah. Hi, this is Dinesh Kumar, and you are watching Oracle videos. In this video, you are watching referential integrity constraints. How can I define referential integrity constraints? This is also called as integrity constraints. In the last video, we have done with domain constraints. How to apply a valid range by using domain constraints, and how to apply a valid list of values on a column. So in this video, we are discussing about integrity constraints. What are integrity constraints? See, let us assume I am introducing two tables. Employee table, here it is having employee ID, employee name and salary. So let us say E1, E2, E3, E4, E5, and here A, B, X, A, Z, and the salaries are 1200, 3000, 1000, 5000, and again 1000. This is the employee information in EMP table. Let us consider department table. In my department table, department ID and department name. D1, D2. Department name production and second department name sales. If you have the data like this, here you are unable to fetch some kind of information from the database. What kind of information you are unable to fetch? Try to find out what I am asking here. Listen carefully. Tell me how many number of employees working under sales. How many number of employees working under sales? Here you have no information in this table. Next, what is the average salary of product department employees? You have no values here. Okay, come to this table. In this table, generally each employee must work under a department. Each employee should work under a department. Tell me department name of E1, no information. And what is the department number of E5? No information. So if you maintain the data like this, you are missing some kind of information from the database. Here these two tables are individual tables. There is no relation between tables. How can I implement relation? So listen carefully. Here we can implement physical relation by using integrity constraints. We can implement physical relation. This is important. So on this concept, we have joins and subqueries. We can implement physical relations between the tables by using integrity constraints. So what is the advantage by defining physical relation? If you define physical relation, you can fetch any kind of information from the tables, and also you can maintain integrity of data among the tables. We can maintain integrity of data among the tables. Okay. So as per our discussion, we are missing some information from these two tables. For this problem, we have two solutions. There exist two methods of solutions. What are the solutions? See, the solution is the first concept, denormalization, and the second concept, normalization. Denormalization and normalization. These are the two methods for this kind of communication gap between database and client. See, what is denormalized data? Maintaining necessary information all together in a big table. Again, I am repeating. What is denormalization process? Maintaining all required information, okay, in one big table is called as denormalization. So let me maintain the necessary information in a single table. Listen, instead of maintaining two tables, let me create as a single table. My table name is EMP underscore DAPT. And my additional columns are department ID, department name. What is department ID? So D1, 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 D2, D2. Here production, production, production. Here sales, sales. Now see here, how many number of employees working under sales? 2 employees. We can easily see 2 records having the value sales. 2 employees are working under sales. How many number of employees working under production? 3 employees. What is the department name of E3? See, E3 is working under production. So what is the average salary of sales employees? Yeah, 5,000 plus 1,000, 3,000 by 2, 6,000 by 2, that is 3,000 is the average salary of sales employees. So now you are able to fetch any kind of information from the database. But there is a problem. What are the disadvantages here? Yes, you have some disadvantages here. What are the disadvantages? See, it occupies more disk space. More disk space. It need more disk space. I will tell you what is that. Let us, second one is data duplicacy. Data duplicacy. And third one is data retrieval time is more or high. Data retrieval time is high. Means it take lot of time to get your required information. Why it is so? All of you see, this is a table having 5 columns into 5 records. How many number of values? 25 values. Let us assume 5 into 5, 25 KB size it is occupying. 25 kilobytes of disk space it is occupying. And data duplicacy. See, as per my simple example, only 2 departments, only 5 employees. Suppose in the real-time company, in any company, 10,000 employees are there. 6,000 employees working under production. 6,000 employees working under production. See, in that case, say here, for each employee working under production, you need to maintain this record. Here, as per our example, 3 employees working under production. So 3 times you are maintaining production information. Whereas, if 6,000 employees working under production, 6,000 number of times we have to maintain production department information. 6,000 number of times you are maintaining same record. Similarly, 4,000 employees working under sales, then 4,000 number of times you need to maintain sales department information, 4,000 number of times. So data duplicacy is very high. And data retrieval time, if more number of values, it will take more time to fetch your data. If less number of values, it will take less time to fetch the data. So data retrieval time is also very high. Now, how can I avoid these disadvantages? Then we can follow normalization concept. What is normalization? So what is normalization? Divide the big table into subtables. Divide the big table into subtables. That is called as normalization. Divide big table into subtables. Divide big table into subtables. This is called as normalization process. So, up to which level we have to continue this dividing process? Until you eliminate the data duplicacy at max. Until you eliminate the data duplicacy at maximum. And one more important point, you are unable to remove 100% of data duplicacy from any type of database. you are unable to remove 100% of data duplicacy from any type of database. Remember that point. Why? Because if you completely remove the data duplicacy, then you are unable to fetch your required information. Why? Let me explain you. Here, normalization. 3 normal forms. Here I am explaining 3 normal forms. What is the first normal form? The first normal form is divide the big table into subtables based on repeated groups of data. Divide big table into subtables based on repeated groups of data. Here, what is the repeated groups of data? See here, from department ID, you have repeated groups of data. From department ID, you have repeated groups of data. So, divide the table up to salary as one table and from DID into other table. Now, you have 2 tables, employee table and department table. In employee table, you have the information related to E1, E2, E3, E4 and E5. In department table, D1, D1, D1 and D2, D2. Here A, B, X, A, Z. Some salaries you are maintaining. And here production 3 times and then sales 2 times. Okay, fine. So this is called as a first normal form. Now let me go for second normal form. What is the second normal form? Second normal form is remove data duplicate records. Remove duplicate records and define primary keys. Remove duplicate records and define primary keys. Let me write this second normal form here and you can clearly understand. And see here I am explaining about second normal form. Here employee table, department table. So what is the use of second normal form? Remove duplicate records and define primary keys. Do you have any duplicate records here in EMP? No duplicate records. And here you are having duplicate records. We need to maintain a department information one time. That's enough. No need to maintain it multiple times. So E1 A some salary, E2 B some salary, E3 X and E4 A and E5 Z. Okay, this is employee data. So if you remove the duplicate records, only you have 2 departments, department 1 production and department 2 sales. So no duplicates, no null values in EID column, we can define primary key. No duplicates, no null values under department ID, we can define primary key. You have 2 individual tables again. So if we have individual tables, we are missing some information from database. So in that case, I can define the third normal form. I can implement third normal form. Here see what is third normal form. Third normal form is also called as BCNF. BCNF stands for Boy's Cod normal form. Boy's Cod, C-O-D-D, normal form. Remember, BCNF is also known as third normal form. And see, what is third normal form? Implement foreign key column in EMP table. Implement foreign key column in EMP table from the primary key of DEPT table. From the primary key of DEPT table, you are implementing a new column that is called as foreign key column in EMP table. How do I? See here, EMP table, actually employee ID, employee name, salary, and here I want to implement department ID. Okay, in DEPT table, department ID, D name columns. So here you are implementing a new column. This is called as foreign key column. Remember, in EMP table you are defining it. So E1, E2, E3, E4 and E5. A, B, X, A, Z. Some salaries are there. So salaries, okay, sorry, just a moment. Yeah, here some salaries. Now D1, 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 D2, D2. Here D1, D2, this is called as production and this is known as sales. Now see here, what is foreign key column? Let me explain about this. Foreign key is a constraint. It should be defined on your column. If you define foreign key constraint on your column, then that column takes the values on which column you have defined foreign key constraint. That column takes the values from primary key. See, from which column you have defined this? From this column, DEPT primary column, primary key column. So only foreign key column EMP table takes the values from primary key of DEPT. So that's why it is taking department 1, 1, 1, 2, 2, 2. It will not accept other than D1 and D2 values. It will not accept other than D1 and D2 values. Remember, sorry, suppose if it is accepting D3, actually it will not accept D3 and D4. Then if it is accepting D4 and D3, there is no foreign key constraint. If there is no foreign key constraint, it will accept other values also. If it is accepting other values, listen carefully, how many number of departments you have? 2, D1, D2. But here you are saying some employees working under D1 and some employees working under D2 and also some employees working under D3 and also D4. But in your business, you have only 2 departments. Then how do you maintain the information like this? Without department, how an employee will work under department D3 and D4? It's impossible. That's why we are defining, so to avoid such kind of invalid values, we are defining foreign key constraint. Then it will take only values from primary key. And foreign key column contains duplicates and null values also. Foreign key column contains duplicates and null values. One sample example. Suppose in a company 100 employees are working. Out of 100 employees, 70 employees working on project 1, 30 employees working on no project, they are on bench. So for the 70 employees, in the employee table, the project code is PRJ1, PRJ1, PRJ1 up to 70 number of times. For the 30 employees who is on bench, so there is no project code. Why? Because they are still on bench. They are not working on any project. Remember, so null values are accepted by foreign key column and foreign key column contains duplicates also. If you maintain the data like this, then there is an integrity, validity among table data. Validity among table data. Based on parent table data, means this is the first table. Based on parent table data, the child table definitely contains valid data. So you are maintaining integrity among parent and child data. That's why we are using normalization process. Here, if you can see these 2 table data, there is no duplicate records. I am not saying about values. There is no duplicate records. First point. Next, data duplicacy eliminated after normalization. Next, it occupies less disk space. See, less disk space. See, no duplicacy. This is one advantage. Advantages. No duplicacy, less disk space, it is taking less disk space, and retrieval time is automatically less. Retrieval time is less. See here, how can I justify my answer? if you see these two table data, there are no data duplicate records. First one. Next, how many number of columns? 4. How many number of records? 5. 4 into 5? 20. And in DEPT table, 2 columns, 2 records. 4 records, 4 values. Totally it is 24 values only. 24 values only. But in denormalized data, we are having 25 values. So, other than normalized data, denormalized data will occupy more disk space. Here you are having less number of records and values. That's why you are having only one value difference is there. If you take more than 7 or 9 records, automatically you will find out 10 values difference, 20 values difference, lakhs of values difference is there. And data retrieval time to process 25 values definitely needs more time than to process 24 values. Okay, so normalization is providing the complete information to the client, and moreover it is reducing disk space occupation, duplicacy, and it is also reducing data retrieval time. These are the advantages by using normalization. Okay, here I am saying you define foreign key column in EMP table. How can I define this? By using integrity constraint. See how to define physical relation between tables by using integrity constraints. Implementing physical relationship is nothing but defining foreign key constraint in a table. Defining foreign key constraint on a column. Okay, how should I? Let me create department table first. So create DEPT table. What are the columns? Department ID. Let us say it is a character of 2, and you are defining primary key. Next, department name. Okay, here varchar 2 of 20. Finish. So we need a table with primary key. Why? Because the same primary key I will use in another table to define foreign key constraint. This is called as parent table. Parent table. Next table, child table. How should I create EMP table? Create table EMP employee ID. It's a character of 3, and this is also primary key. Just for simplicity I am maintaining less columns, don't worry. Employee name, it's varchar 2 of 20, that is not null, and immediately I am defining foreign key column. I am maintaining department ID, and I want to define a foreign key constraint on this column with user friendly name. See, constraint, it's very simple. Constraint, what is the user friendly name I want to maintain? Foreign key on DID column under EMP table. What kind of constraint you are maintaining here? Foreign key. Let me continue here. Foreign key. Foreign key you are maintaining on which column? Department ID. Okay. Then into this column we are referring the values, references. From which table it is taking values? DEPT. And from DEPT from which column? Department ID. Finish. This is the way of creating EMP table. So have a look in the system how to create parent table, how to create child table.